So in the first stage, XRF can help by providing us elemental information. For that, of course, I am thinking about elements heavier than, let's say, iron, not carbon and oxygen. So there, it can already help you just eliminate some potential elemental composition suggested by MS software. As of course, when you're using MS software, you already have to indicate which elements might be present. And if you select too many elements, especially if you were to select the entire periodic system, the amount of options you get is just way too high to really start to identify which one it could be. So by having your XRF already tell you, okay, these elements are definitely present, you can really limit these options. Also, because we have noticed that sometimes in MS software, especially structures with halogens are not prioritized and they don't suggest it even though it is present. So by using your XRF, you actually immediately see, oh, this is present, so it has to be in my elemental composition suggested by my MS. And then in the second stage, it would allow you to immediately quantify your compound. Either you identified it with the MS and then you don't have to rerun anything, you already have your calibration curve. So you can just immediately quantify it based on a specific element that is in common with your standard. But also if you are not completely sure yet about the compound, but you have like a suspected compound, you could already quantify it and have a potential quantification of that unknown compound. So in terms of throughput, there's not really a limitation from the XRF side, as it does not slow anything down. So it will be quite similar to a regular HPLC environment. I think it could actually be a bit faster, as you don't have to create individual calibration curves or optimize individual methods. We are also already currently using our own software, for which I have to credit my coworker Peter Tak, which is becoming more and more accessible and easy to use and comprehensive. And I really believe it can become a simple software that can be used by non-experts in the future. And you can, to imagine what you would have, it's just a software where you could just select an element out of the periodic system that you are interested in and get a calibration curve for that one and get chromatograms based on that element. Or even more for on-target analysis, you could get a 3D image, which just shows all the energies from the XRF spectra as a function of time, which can help you identify which elements are actually of interest, after which you can then select the one you think that might be present and get your chromatograms. In terms of sensitivity, that's the main limitation currently. The best sensitivities we achieved at the synchrotron, which were right below 1 ppm for bromine. But there are some features that we did not take advantage of yet when we were there. For example, in my talk here at HTC, I also talked about HPLC miniaturization and how it can improve our sensitivities. So that we did not do yet at the synchrotron. And on top of that, when we went to the synchrotron, we were obligated to use a less advanced detector that we had to place a bit further from our sample to avoid oversaturation. And it was actually at 2 centimeters, which is quite far. But we know that if we would just use a more advanced detector, which is already available over there, and place it closer to our sample, we can significantly improve our detection limits, just like we did on our lab-based system. Yeah. To get optimal sensitivities, we will really require a combination of advanced X-ray sources, optimizing our flow cell further, advanced X-ray detectors, and HPLC miniaturization. For the sources, we can of course think about the synchrotron, which we also used, but that is of course not a routine application. But in the past, they have been a good predictor of what we can expect from lab-scale X-ray sources in the future. And there are already more advanced X-ray sources on the market for lab-scale systems that we did not use, like the liquid metal jets. But then of course, we are looking at a different price range. And when it comes to advanced X-ray detectors, I really think we need to work on that overhead time to reduce that. But we can also use more advanced techniques like a multi-element detector or confocal detectors, which will also significantly improve our sensitivities. Now, the flow cell, I think, can also be further optimized. So we definitely have not reached the end yet when it comes to that. But of course, every new design will need to go hand in hand with how does it influence our separation and how can we make sure that our separation efficiency is not limited. Now, when it will actually be able to come a routine technique for environmental analysis kind of depends. It's hard to say which feature will be the most important or will actually make us achieve the desired sensitivities. Of course, combining them all will give us the best results. but maybe only 1 or 2 features will be required to reach the sensitivities that we need. And how fast this will be done kind of depends on how many people can work on it, on the project, and the budget that we have for it, and for the specific application, what the desired sensitivities are. Overall, I think we can expect this technique, at least we needed 5 years or so more to really get it to a point where it could be routinely used. And in that time, I think the HPLC miniaturization, the flow cell design, and the detectors could definitely be optimized. For the source, we're a bit more dependent on the XRF world. So I really think this project would benefit from a further collaboration between experts in the XRF environment and the chromatography world.